Fine. Next, let us take up the case studies on this input and output operation. So when I say that here I am taking just the different cases, like where for reading and writing process we may be using the TD, RD and WD. I hope you remembered. So now first let us take up this problem statement, which is read 100 characters, right? I'll just say this. First I'll take up the first case study. Read 100 characters. This one. Read 100 characters from the input device and store into a memory space. Then that name of the memory space, it is given as record. You call it as a record or the buffer, whatever it is left you call it as a message. So it's not the name which matters. So what matters is how you are going to demonstrate, how you are going to store the data in the particular memory space. That is the matters, not the names what I will be giving, right? So before I take you to the actual process, so if you can able to understand from the previous examples as well, right? So what I'll do, I'll just go with the label part, opcode and the operand, right? So however, we spoke about this so many times in the theoretical part as well. Before you can start reading the data, writing the data, you have to test that particular device. Which device? When you will be reading the data, in the sense you have to test the input device for whether the device is ready or not. I hope you know that, for which itself will be using the TD for testing the device. If the device is quite ready, then only you can start reading the data. If the device is not ready, you will have to wait for it. So I hope you remember that story. So we have discussed in the theory part. For your understanding, I can also write that with respect to diagrammatical. So here if you observe, this is what I call it as the input device. And also when we spoke about the theory, I also gave you that input device number which we are going to use in our case, which is nothing else, F1, which is the input device number. See how it works in a sense, basically my dear students. So this is the input device, right? So here is the input device. So as soon as you read the data from the input device, so where it will be stored, in a sense it automatically it will get stored into the accumulator register. I repeat, it will be stored onto the accumulator register, right? Which is a default register. I hope you remember accumulator register. Once it's stored into the accumulator register, then from there, okay, from that accumulator register, you need to push it onto the any specific memory space wherever you would like to store. And here it is mentioned that the name of that it is supposed to be record. So what I will say, once after it is stored onto the accumulator, I will say loaded into the accumulator register, that again you should store onto any memory location. This is how it goes out. Okay, so you can push it onto the memory space or memory location, whatever you call it as. So this is how the flow which will happen. First you need to test this particular input device. Okay, you need to test this device. If the device is ready, then read the data by using your RD as usual. Once after you read, automatically I said it will be stored into the accumulator register, that you can again store back onto the memory, right? Is it clear? So the same way, let us start doing. So first let me declare this input device number. I'll say input, right, or in I'll say input device. So input device number, and as I know the input device number, which is F1, and that F1 is in the hexadecimal, so I'll have to say X F1. It is hexadecimal. At the same time, I'll need to have a record as one of the memory space, because that's what the problem in the problem definition is given, and it should have the 100 characters. So I need to allocate the memory space for it to hold the 100 characters. So I'll say reserve byte 100, right? So I record with the reserve byte 100 is initialized. Clear? Now when I will be generating a program right here, as usual, first if you want me to generate it first in SIC, then I'll take it to the SICXE. So what I'll do, I'll just put this in the mid. Yeah, how much ever it is possible, I'll just take it out. This is the input device and this is the memory space. Try to get it right. So first let me write the SIC, where I'll be reading the 100 characters. So I'll say read itself as the name of the program. I'll say and start 1000, anything for that matter, as usual. So as I'll be reading 100 characters, so in case of SIC I have to declare as well, whenever I'll be initializing the X register, right? Whenever I'll be initializing the X register, I have to first declare, I'll say 0 word 0. At the same time, maximum, how many times I want to read, how many characters, it is the 100. So I'll say max 100. Okay, now let us start. So here I'll just initialize LDX with the 0. What is this 0? 0 is we initialize with the value 0, right? You see, my dear students, first, as I mentioned, you will first need to test the device. I need to test the device. Which device? It is the indiv. And test the indiv. If that is equal, that's what. If it is equal, the device is not ready. So only say that JEQ. If it is equal, I'm not supposed to go for the reading process. I need to keep waiting. For that itself, I'll say loop. Where is the loop? Here I'll say loop. Okay. If the device is set as equal, so I'm not supposed to go for reading process. I have to keep repeating this process itself. If the device is not set equal, if it is set to less than, if it is not equal, definitely it is defaultly it is less than. So in that case, I have to go for reading. So I'll say RD. From where? From the indiv. As I mentioned, as soon as you read, okay, as soon as you read the data from the input device, where it will be available? It will be available into the accumulator register. That I have to push it onto the memory location. In my example, memory location is what? Record. So here, how to store the data from the register, which is which register? How to store the character from the accumulator register onto the memory space, for which we'll be using a SDCH. Yes, correct. So we'll be using the SDCH. So SDCH record, X. What is X? X is being initialized with the 0 earlier. Then later I'll be incrementing TIX and comparing whether am I done with reading 100 characters. How to check with that? Because max is the one which is initialized with the 100, so I can compare with the max. So I'll increment X and compare with the max. Okay, I'll compare with the max. If I am not done with the reading all the 100 characters, so the X will not be say equal to max, which is 100. So it is less than, so I need to jump to the loop and repeat the same thing, and at the end I'll be having a end instruction. That's it. This is the program in the SIC for this particular process. If you ask me in the SICXE, what changes I'm going to have? So by now you may be having that idea what are all the changes you may have when it comes to the SICXE. So first and foremost thing is that you don't have to declare these constant values with any memory space in case of SICXE, is it not? And these will be, as usual, will be available, right? These lines, okay, these lines I'll just say, yeah, here, and so I'll just remove it off here, wherein I'll be making the 2 additional register like LDT for storing the 100, the maximum, and also I'll be using 0. Again, I can directly initialize 0 with the hash 0, is it not? I can directly initialize LDX hash 0, LDT 100. As usual, test the input device. If it is equal, jump back to loop and keep performing. If it is not, read from the input device, STCH buffer record, X. That's quite good. And here instead of TX, we'll be having TXR, and instead of max, we'll be having the register T, because T is the one which will be having the maximum count. That's it. That's only the difference when it comes to SICXE program. Are you getting, guys?